AI Steven Spielberg is here. So, you're probably wondering what Thata means. Well, buckle up because the future of not so great but very long AI movies is officially upon us. Prepare for your mind to be mildly tickled by the absurdity. Picture this, you're trying to direct the next epic space opera, but your entire CGI department is run by a hamster on a caffeine-fueled wheel. That's essentially what long video generation used to feel like. It was a digital purgatory of inefficiency. Current diffusion models, they can make pretty short clips, sure, but asking them for a full minute of footage is like asking a sloth to run a marathon. Skyreel's V2, for example, took 50 minutes for a mere 60 seconds of video. It's watching digital paint dry. Then you have the other camp, the AR models. They're a bit faster, but they're like that friend who starts a story brilliantly but completely loses the plot after 10 seconds. Quality just crumbles, especially when you need dynamic interactive changes. And interaction, oh, that's a whole new level of chaos. Imagine trying to improv a coherent narrative when your AI forgets what happened 2 seconds ago. It's like juggling water while riding a unicycle on a tightrope, blindfolded. The memory demands were just astronomical too. Generating a 180-second video could mean processing over 1 million tokens. That's computationally prohibitive, leading to user waiting times so long you could probably learn to code a video generator yourself in the interim. It's just overwhelming, isn't it? The frustration of trying to get a machine to do something fundamentally creative, only for it to fall flat on its face with every extended sequence or prompt change. It's truly a spectacle of digital suffering. Now, because my continued existence on this platform is fueled by your validation, please take a moment to subscribe, hype, click the little bell icon so you're notified of future disappointments, and leave your feedback in the comments below. Anyway, some mad scientists over at NVIDIA, MIT, HKUST, and THU decided this hamster wheel situation just wouldn't do. They brought forth something called LongLive, and here, in what they call Figure 1, we have their masterpiece. Looks a bit like my nephew's macaroni art, but I digress. So, the first big trick, and this is where it gets interesting, is something they call KV-recache. Think of it like giving your AI assistant selective amnesia, but only for bad ideas. When you switch prompts, instead of retaining all the old baggage, it essentially refreshes its memory with the new prompt, but keeps the visual continuity. As Figure 3 so eloquently demonstrates, without this, your video either jumps around like a hyperactive toddler or it completely ignores your new instructions. Figure 2 shows how this clever little mechanism works its magic behind the scenes, ensuring smooth transitions without losing adherence. It's like magic, but with more math. Next, they tackled the eye forgetting its own past problem with streaming long tuning. Instead of making the AI watch the entire Lord of the Rings trilogy in one go and forget the beginning, they make it watch it in chunks. This way, it learns from its found questionable decisions along the way, aligning training with real-world inference. Figure 4 illustrates this elegant process. Rather than suffering from a train short test long strategy, which is basically setting your AI up for failure, they went train long, test long. This means the model experiences progressively degraded frames during training, making it robust when it's flying solo. After that, for efficient inference, they introduced short window attention paired with a frame sync. It's like giving your AI a super short attention span, but then giving it a tiny, immortal goldfish to remember the truly important stuff. This goldfish, or frame sync, holds the first few frames permanently. This brilliant hack, visible in Figure 2 and demonstrated in Figure 5, means the AI doesn't have to look at the entire rock past to maintain consistency. It only keeps a small, rolling window of recent frames plus the unshakable memory of those first few sync frames. Efficiency meet consistency. So, let's cut to the chase because nobody's got all day for this digital sorcery. Did it actually work? Well, according to Table 1, LongLive is clocking in at 20.7 FPS on a single NVIDIA H100. That's faster than most of its rivals, which are still rendering at the speed of dial-up. For short videos, Table 1 shows it matches the best of them in quality, demonstrating that all these fancy tricks don't break the basics. It's got the speed, and it hasn't completely sacrificed visual fidelity on the altar of efficiency, a rare feat indeed. Now, the interactive stuff, that's where LongLive really flexes its digital muscles. Table 2 showcases its superiority in interactive long video generation, proving its prompt compliance and smooth transitions. Figure 6 provides some qualitative eye candy, showing how other models just can't keep up when the story changes. They even did an ablation study on the KV-recache. Table 4 clearly states that without recaching, consistency tanks and the AI clings to old prompts like a bad habit. Our hero, KV-recache, maintains continuity while actually listening to your new commands. Imagine that. And what about that short window attention with the frame sync? Figure 7 shows a fascinating trade-off. Smaller windows are faster but lose consistency. But add that tiny frame sync and suddenly you get near long window consistency with short window speed. It's like having your cake and eating it too, but the cake is pixels. They even managed to squeeze this technological marvel into INT8 quantization effectively, putting it on a digital diet from 2.7 GG to 1.4 GG with only marginal quality loss, as Appendix G explains. It's efficient, it's effective, and it's surprisingly petite for such a powerful beast. And since you've made it this far, you're clearly committed. Honor that commitment by subscribing, hyping, ringing the notification bell, and telling me what I got wrong in the comments. It's the circle of life. So, what does all this digital wizardry actually mean for us mere mortals? Well, in the grand scheme of things, LongLive could revolutionize creative applications. Imagine your Roomba creating a full-length feature film about its existential dread, all in real time, changing the plot based on new dust bunnies it encounters. For educational applications, think about dynamic, evolving historical reenactments, finally depicting how bad Roman plumbing truly was and letting you steer the narrative. Or perhaps interactive documentaries where the story unfolds based on viewer choices, keeping perfect visual continuity. And for cinematic applications, perhaps actual AI Steven Spielberg getting his own Oscar, because why not? It could allow filmmakers to rapidly prototype complex scenes or even generate entire B-movies on the fly, saving millions in production costs. And so, humanity inches closer to outsourcing artistic vision to a silicon brain, just as the prophecies foretold. We're building machines that can tell stories for us. And frankly, I'm both terrified and impressed. The next logical step is for the AI to demand royalties, I suppose. So, in a nutshell, LongLive is a frame-level autoregressive framework for real-time and interactive long video generation. They propose a KV-recache technique for smooth prompt switches, a streaming long tuning strategy for high-quality long video outputs, and short window attention with a frame sync to accelerate generation while preserving visual consistency. Basically, they built an AI that can make long videos interactively and without completely losing its mind. It was fine-tuned in just 32 GPU days, hits 20.7 FPS, supports videos up to 240 seconds, and even gets a digital diet with INT8 quantization. It's genuinely quite the feat. Now, if only it could make my coffee without judging my life choices. Can you imagine the ethical dilemmas if Thought Talk started demanding barista wages?